So 1.5 divided by 2 power 3 times by shift pi divided by 2 times 14.272 power 3 is equal to 9.458 times 10 to, let me write properly, 9.458 times 10 to the power 3 psi. 8 psi. Eugene, seriously? How inch? Okay. So when you apply hormesis, we still have to do a check. Okay, so the normal thing to do is we are going to check that stress A and stress B are less than what? So the question has to be less than 42 times 10 to the power 3 psi. Okay, we have to check. So stress A and stress B will be equal to what? Will be equal to stress average plus or minus by what? The radius, yes or no? So it's stress average plus minus by R. So the stress average, the average that we got earlier is what? Minus, what is our stress average? I'm lost now. Stress average, we calculate earlier. Stress average, where am I? Minus 16.977. Minus 16.977 times 10 to the power 3 plus or minus the radius. So the radius we acquired is equal to what? 22.179. Is equal to 22.179 times 10 to the power 3. So this will be equal to 16.977 plus 22.179. So we have minus 39.156 times by 10 to the power 3 psi. And the other end, minus 16.977 power 3 plus by 22.179 power 3 is 5.202. Okay. So if the question were to ask you to calculate the factor of safety, it's equal to 42 times 10 to the power 3 divided by, you pick the higher number. Okay. So the factor of safety, 42 divided by 39.156 is equal to 1.073. Okay, that is your factor of safety. Are we clear? Yes. You have to, if I ask you to calculate your factor of safety, you have to check, right? Yeah. I'm not going to tell you if I'm going to or not going to, okay? Right. So I want to, at the same time, so this is, what do we use for this? We use what? We use hormesis, right? Now I'm going to do the same thing and I'm going to apply Tresca. Okay, so now I'm going to apply Tresca criteria. Okay, I'm going to apply Tresca criteria. So with Tresca criteria, we know that tau max is equal to stress yield divided by 2. So this will be equal to 42 times 10 to the power 3 divided by 2. So this will give you what? 21 times 10 to the power 3 psi. Okay, 21 times 10 to. So this is equal. So this has to be the what? Largest radius in the what? 3D mole circle. Okay. So the same diagram. Yeah, I'm going to use the same diagram. Come on. Okay, whether is it hormesis or Tresca, mole circle is always the same. Okay, so I'm going to shift this across. Now we're going to apply Tresca criteria. So 3D mole circle is always the same. And for this case, what we know is that stress A and stress B are not equal to 0. Okay? So if that's the case, we can apply what? Tau max is equal to half absolute value stress A minus by stress B. Okay? So now we are going to look at what is stress A minus stress B is. So stress A minus stress B is stress average plus by radius, like what we had before, right? And then we have what? Minus by stress average minus R. Okay? So we have this will be equal to what? 2R. Okay. So stress A minus stress B is we get what? 2R. Okay. So from here, right? Stress A minus stress B equal to 2R. Okay. So from here, we know that tau max, okay. Sorry, I forgot something. So therefore, tau max is equal to 2R over 2, right? So when you cancel, so tau max is equal to R. And we know that tau max is equal to 21 times 10 to the power 3. And then the radius will be equal to what? Right? So the radius, what we know about this now, this one is slightly different now, okay? The R over here, we know is equal to 21 times 10 to the power 3. Yes or no? Right? So this is 21 times 10 to the power 3 squared. And then minus by the stress average. Stress average is still the same. So it's equal to 16.977 times 10 to the power 3 squared. Okay. So from here, this will be equal to what? This will be equal to, what am I doing down here? This is shear XY. I do apologize. Okay. So we still want to determine what is our what? What is our shear XY? Okay. So shear XY will be equal to 21 power of 3 squared minus by 16.977 power of 3 squared. Square of whole thing is equal to 12.36 times 10 to the power 3 psi. Okay, so again, the same thing again. So now we know that torque, okay, I don't skip step, okay. Gxy is equal to TR over J, okay. Like what we have applied before. So we know that the torque is equal to shear XY multiplied by J. So J is half C to the power 4 divided by the radius C. Okay. So I have a pi missing. So what we have down here is now 12.36 times 10 to the power 3 multiplied by pi over 2 multiplied by 1.5 divided by 2 squared. So 12.36 power 3 times by 3 pi cube, Eugene. Come on. It's almost the end. So it's equal to 8.19 times 10 to the power 3 psi. Right? So this is based on Tresca. Again, we have to do the check where we have to determine our stress A and stress B. So it's equal to minus 16.977 times 10 to the power 3 plus or minus 21 times 10 to the power 3. So 16.977 power 3 is equal to minus 37.977 times 10 to the power 3 psi. And the other one will be 4.023 times 10 to the power 3 psi. So based on Tresca, the torque allowable is equal to what? 8.19 times 10 to power, no, it's not 8.19. Yeah, it's 8.19 pound inch. Okay, pound inch. And then based on vormesis, the torque allowable is equal to what? Is equal to 9.458 times 10 to power 3 pound inch. Okay, so if the benchmark, okay, if the benchmark is Tresca, benchmark means the reference, right? The increase in torque will be equal to what? 9.458 minus by 8.19 divided by 8.19 times by 100. Okay. So 9.458 minus 8.19 divided by 8.19 times 100. The difference is 15.5%. Like what I told you before, vormesis is less what? Conservative. Okay, so you can see the difference. Okay. So to summarize, okay, to summarize, if we were, so there are two criteria. One is known as maximum shear. The other one is based on maximum distortion energy. Okay, maximum shear stress. So we know that one is known as Tresca and the other one is known as vormesis. Okay. For this case, stress or tau max, maximum shear stress, is equal to what? Stress yield divided by 2. For maximum distortion, it's just stress A squared minus by stress A stress B plus by stress B squared. Has to be less than stress U squared. Right? Then from here, we know that stress U is divided by and then tau max. Okay. So for both of them, you have to construct what? Construct excuse me. Yeah. You okay over there? You ask me a question. Then I don't want you to disturb the rest of the class because your voice is echoing over here. Okay. So for both cases, you have to construct 3D Mohs circle. Right? You have to construct 3D Mohs circle. Why is that? Is because on one side, if you look at Tresca, tau max has to be what? Stress A minus stress B divided by 2. On vormesis, you also need to have your what? Stress A and stress B. Right? You want to be sure that when you construct your 3D Mohs circle, right? When you construct your 3D Mohs circle, you want to ensure that this value over here is your stress A, and this value over here is your what? Stress B, or vice versa. Are we clear? Okay. And then the rest is all the same. Okay. Okay. How you get, so once you got all these values, like what we found earlier, once you found those values, you know that your radius will be equal to what? So we know over here that the common thing is stress A and stress B is equal to what? So hold on. Let me put this on another piece of paper. So you know that for both cases, the common thing is what? For both cases, stress A and stress B is equal to what? Stress average plus or minus by the what? Radius. Then you find these values, then you determine the stress A and stress B. Then you have these values, you substitute them in here, and you substitute them in here. Are we clear? This is what? This is the summary of the U criteria. It's not difficult at all. The only thing that is difficult is the analysis. What do I mean by that? Breaking down what I'll give you a very quick example. Okay, this is a very quick example. You look at the problem like this. Look at the problem. One question, whatever you learn after buckling to the end of the course, including Wk14. One question. Okay. So we have a question coming up something very similar like this. With very similar. Very similar, all these ones. Okay. So so this course